In this video lecture, we're going to be looking at the implementation of decision trees within the scikit-learn library in Python. And before we begin, I want you to install this graphviz package in Python using pip. It'll allow us to visualize decision trees graphically. Graphviz also wants you to install a side-along executable, but what we're going to do is just install this package and use a website to visualize our trees. I'll first begin by importing the pandas library as always, and we're going to be using the tennis data we talked about in class last time around, and this CSV is currently available on the GitHub repository, so you're able to grab it whenever you want. Let's look at the head of the data set. So you have outlook, temperature, humidity, windy, and you're trying to predict if a person plays tennis or not. I also want you guys to look at the info function here. And other than windy, which is a Boolean true or false value, everything is currently stored as a string object. Now, you might want to convert them all into categories right off the bat and see if that'll work with the model, but we're going to run into a couple of issues there. So if I were to think about converting them into categories, they're still going to be string values. So sunny will remain sunny, it's just that it's now a categorical attribute. And the current implementation of decision tree classifiers in scikit-learn only allow numerical data to be parsed, so integers or floats. So you might then say, okay, what if I were to, let's look at all the data here, there are 14 of them. What if I were to then say, okay, sunny is 1, overcast is 2, rainy is 3, and so on and so forth? Well, in that case, you're not converting your data into categorical values, you're sort of making ordinal, so there is an order. And by that, I mean that if sunny was 0, overcast was 1, and rainy was 2, your function, your model is going to assume that rainy is somehow better than overcast, which is better than sunny. So directly converting these into categories and directly converting these into like 0, 1, 2 values, ordinal values, is not going to cut it. So instead, what we'll have to do is we'll have to use one-hot encoding here. We'll first split our data into our independent and dependent variables, and I'm going to start by doing x is tennis.iloc, this thing. So within the iloc function, you're able to specify what rows you want and what columns you want, comma separated. And if a colon is there by itself, that just means give me all the rows, but I'm going to do this to grab the first 4 columns. So index 0, index 1, index 2, and index 3. So the 4 is exclusive. And then for my y value, which is just play here, I'm going to do tennis.iloc, give me all the rows, but give me the last column, so index 4 column, which is going to be play. Okay, so to one-hot encode, we're going to use a library, sklearn.preprocessing import one-hot encoder. The idea behind one-hot encoder, again, is that at one point in time, you're going to, so if you had Outlook, which has 3 categories, the encoder will convert them into 3 different columns, where for every row, only one of them will fire 1 and the other 2 will be 0. And so if I'm able to run this code, I'll show you what exactly is happening. So I'm going to first initialize our encoder, and then I'm going to fit all of my independent variables that I want to convert, and we'll make a new data set out of it. Transform x.toArray, and let's just do a data frame, which is pandas. And the columns, is a rather smart way of doing it, is to get this column name Outlook. So remember, when I one-hot encode this column, the Outlook column, it's going to create 3 new columns, one each for sunny, overcast, and rainy. And the code I'm about to write is going to give them correct names. It's going to give them Outlook underscore sunny, Outlook underscore overcast, and Outlook underscore rainy. So we're able to easily visualize what's going on here. And feature underscore names, x dot columns. And if I were to do this, encode x, uppercase, you'll see that Outlook was converted into 3 different columns here, one for each of its categories. So Outlook overcast, Outlook rainy, Outlook sunny. Temperature, which had cool, hot, and mild, is also converted into 3 different columns. Humidity is converted into 2, and then also windy converted into 2. And so I want you to focus on just the 0th row here. Outlook sunny is 1, the other 2 are 0. Temperature cool and hot, cool and mild are 0. Temperature hot is 1. Humidity is high is 1, normal is 0. Windy false is 1, windy true is 0. So this is happening because your 0th index said the outlook was sunny, the temperature was hot, humidity was high, and it was windy was false. So based on this data set, you're giving a 1 to whatever was encoded in that scenario. So if at, let's say row index 2, you had outlook to be overcast, you'll notice that overcast is 1 and the other 2 are 0. And then the temperature was hot, so cool and mild are 0. Hot is 1, and the same goes for humidity high because it was high humidity, and windy is false, so you'll have a 0 for true, 1 for false. And so in this way, you're not actually making ordinal data. You haven't encoded them into classifications, so you haven't encoded them into categorical values, you haven't encoded them into ordinal data where 0, 1, 2 might be problematic, where your model is going to assume that these were true numerical data. Instead, you're only going to be playing with a bunch of zeros and ones. And this is the right way of converting your categories into one-hot encoding to then be able to use in a decision tree classifier. I'm going to now get the train test split, and we're going to get our x train, x test, y train, y test, using this train test split. I'm going to use the encoded x's here. The y remained the same. We don't need to encode our y values. And because this data is only 14 rows, I'm going to use a 30-70, 70-30 split. Usually we go for an 80-20. And I'm going to assign a random state to be, let's say, 10. The random state here is just a seed. And so we know that the training and testing split is happening randomly. So if you wanted to compare your results with mine, you can just use this random state equals 10, and you're going to get the exact same split going on. I'm also going to show you the shape of X train, and it's going to look somewhat peculiar, but again, the idea here is that it's 9 rows, and I have now 10 independent variables. So all 10 of these. Now, this could lead to some issues. If you have a small data set with a lot of features and a lot of categories within those features, so say you had a couple more columns with 4 categories each, so instead of outlook being sunny, overcast, rainy, let's say there were 4 of them here, you're going to keep increasing the number of independent variables you have. And right now, you have more features than you have then you have rows, and that's not a very good model. So you have to be aware of how many features you're actually using in your model going forward. So I'm going to continue, and I'm going to then import our decision tree classifier. And I'm just going to go with CLF. So the same routine, I have to initialize it first. And I'm also going to give it a random state, so we all get the same results. Let's give it 100, and then I'm going to fit my X train with my Y train. Okay, and then we're going to also predict CLF dot predict from my X test values, and I'm going to import the accuracy score function to see how well our model performed. Now, whatever accuracy you get, I will tell you it's going to be very, very volatile because you're only training 9 data points on 10 different features to then test on 5 data points. It's not going to be the perfect model you'll see, but let's see what it comes out to be. Y test with predictions. Accuracy underscore. There we go. Okay, 80%. That's good, but I still have reservations about if it's good, or it's because it's very overfitted, our data set. So we can now actually visualize what our decision tree generated was. So to do that, I'm going to import this function and also the library we just installed, and we're going to call in a export GraphWiz function with multiple attributes, with multiple parameters here. So the first one is going to be your classifier. Next, you're going to specify what your output file should be, and I'm going to call it tennisdt.dot. So you need to specify that it's going to be a .dot file. That's what gets exported from GraphWiz, and that's what our website will take as input. And next, you need to specify, comma, your feature name, so the name of the columns you have, and so we have 10 of them, and they're currently stored in encode_df dot columns. You also need to specify filled equals true, so it gives us a nice color, and then I'm going to also say rounded equals true for a nice shape. Okay, when I run this, I will get a file that looks like this. You can make sense of what's going on here, but instead what we'll do is we'll copy the entire thing, and if you were to look up GraphWiz online on Google, you're gonna get this first search result, and you just paste your .dot file text in here, and that's the tree, the decision tree you get from your classifier. Now this is currently built up on your training data only. The testing is only for the accuracy. Let's now look at what this actually sort of means. So I've copied out the decision tree that was generated, and let's try to see if we're able to make a decision tree out of it as we have done in class. And so remember that all of these values are either going to be 0 or 1. So if you're confused by overcast less than 0.5, that just means if it's 0, then do that, otherwise do this. So we're going to start by, let's see, Outlook overcast. That's our root here. Okay. And less than 0.5 means if it's 0 or not. So we can say that if it is in fact false and if it is in fact true. So if it's going to be greater than 0, you're sort of greater than 0.5, that's a 1 value you're going to get here. Okay, and then that's further split on humidity, which is normal. Okay, and that's further split down in the middle here. So humidity normal less than 0.5, which means that it's going to be false here, true here. So if it's greater than 0.5, that means humidity normal was true, so I'm going to make it true or false here. And here you end up with your first playing tennis, your first pure leaf node. And so another thing to note here is that you'll see value 30. This is currently reversed, so you get the no's first, the yeses next. So it actually is going to be, 0 no's, 0 yeses, 3 no's. And then humidity normal, which is true, is going to get broken further down into windy false. Okay, and now if that is true, windy false, again, less than 0.5, meaning this is going to be the 0th. What happens when windy false was 0, which means this is false again, this is true, and you're going to have outlook rainy again. Outlook rainy. So the outlook is sort of scattered here. Outlook overcast in the beginning as a root node, and then outlook rainy all the way down here. And that is being further split into your final play tennis or not. So that's going to be reversed. So 0, 1 becomes 1, 0. Outlook rainy false again. So if outlook was less than 0.5, which means it's 0, which means it's false, you're going to get this. And if it is in fact true, your yes or no are going to convert into 0 and 1, so the reverse of that. Windy false is going to become another pure root node. Yes and no. Reverse that, you'll get 2 and 0. And finally, this is also a pure node, which gets 2 or 0. So what this data is, what this decision tree is telling you is that if the overcast is ever, if the outlook is ever overcast, so if it is in fact true, then you're always going to play tennis. And then if it is false, if it was not overcast, it could be rainy or sunny, then you're going to check what the humidity was. And if the humidity was normal, you're going to further split. But if the humidity was not normal, so humidity was high or anything else, then if the outlook was not overcast and the humidity was not normal, then you're not going to play tennis ever. And so that's how you're sort of going to be converting this GraphWiz version of a decision tree into some sort that we have already looked at before. Next, we're going to look at an example using the iris dataset. So the iris dataset is good because it has just numerical data. So it'll be interesting to see what sort of visualization of a decision tree we get and what sort of accuracy we get out of it. So I'm going to load the built-in dataset of iris, and we're going to do import iris, and then iris is going to be iris. And please remember that this is not going to be a data frame, it is actually a bunch, so you're not able to do the train and test split right away. Instead, what you'll have to do is say x is iris.data, y is iris.target. So the bunch data type basically separates out your independent variables and your dependent variables into data and target. So it makes it a little bit easier to grab the information that you want. So we're going to still go ahead and split our data into training and testing. And for now, I'm going to do 0.2, so 80-20 split. And also let's do random state of 100. So we're able to rerun the exact same numbers here. Okay, and for that, we already have our classifier initialized, so I'm just going to fit this new data set in there. Okay, I'm also going to use my predictions. So classifier dot predict x underscore test, and then calculate the accuracy score for y test and predictions. Okay, 97% accurate, this decision tree. Okay, I'm also just going to copy this part here, so the graph width part, and instead we're going to call it iris_dt, and then this makes things nicer too because we're using the bunch data type. I could just do feature underscore names, and I can add this too because the iris data set is now going to be for 3 different categories. So I want to see what went where instead of just a 0 or 1. So I'm also able to do target names. Class names. Class names. There we go. After running that piece of code, this is what the DOT file for iris will look like. I'm going to copy and paste this into the website and show you guys the results. This is the final decision tree you will get for the iris data set, and you'll notice that because this is all numerical data, you don't have a perfect in the middle split going on for any of these values. Instead, the classifier found the best splits for the numerical value to make itself. And you'll notice that just for the first split, if the petal length was less than 2.45 centimeters, you're already able to classify 39 Setosa flowers right away, 42 versicolors after a third level split, and after a third level split, you are also able to extract 30 Virginica. For the remaining ones, where the decision tree was still unable to put them in chunks here, in these 3 chunks, it made more splits, and you were able to get finally, you're still able to get all pure leaf nodes at the very end. So I'm going to let this one be exercise for you guys to convert this into the form that we have been more familiar with, just like we did with the tennis data set. And we're going to look into more examples and in class assignments in class on Wednesday.